We're going to look at creating periodic graphs from data. So this is the information we've been given. A periodic function has a period of 6, an amplitude of 3, and an equation of axis is at y equals 6. So there's actually a lot of compounded information in there. First of all, it's a periodic function. Okay, and we'll talk about what that means. And the period is 6, amplitude is 3, and the equation of axis almost everything in there was important. So if we were to sketch something like this, let's say we're gonna just kind of build our graph. Okay, we don't know too much about this periodic function. The first thing we do want to point out is a periodic function is something that repeats. Okay, so they'll talk about sinusoidal, and sinusoidal has this wave pattern to it, and it is also, those aren't identical, they should be. Is also periodic. If drawn identically, they have this type to it, and we can show what that would be. Like this guy here, this is sinusoidal, has that wave to it, and it's periodic because it repeats here at 0 and then here at 2 pi at 0. And don't worry about what that. That's like 6 point something ish. This function here, a function we don't have to know, but just to show, is periodic. It would repeat roughly, actually not at that point, and here. It would repeat here because, just to talk about this idea, it goes up, down, and then it's coming up again. And that's where we last left off, where it was coming up, okay? So that's kind of important. We could also say it repeats here. There's so many different places where we can cut the period of this function. We could say it repeats in the exact middle, and this is the repetition. That's what's neat about periodic functions. It's not sinusoidal because it doesn't have that wave type to it. It is very wave-like, but this is period. So we're focusing on how many different periods we have to this function. So ours, what that means is it can do many things. We just have to make sure it repeats after 6. So let's give ourselves a scale here and tell us what it was. So maybe we'll say it's time in seconds, and this is maybe height. Okay. So we have 1, no, 0. There we go. 1, 2, 3, 4, 5, 6. That's right. Okay. 7, 8, 9, 10, 11. I do want to get 12 out there. Okay, good. The equation of the axis is y equals 6. They've literally given you an equation. In order to build this scale, I need to figure out where my equation of the axis is first. So let's say I want to put my equation of the axis roughly in the middle of where we are. 1, 2, 3, 4, 5. We'll extend it a little. So the middle would be roughly here. So I'll say that's the number 6. Okay? And what it's telling us is that there's a line going through this function, an imaginary line, right there. Okay? And an example of that, I'm just going to move this one up a little, 3. Okay? There would be an imaginary line, y equals 3. This green one would be the equation of the axis of this one. It cuts right through the middle of it. The reason I moved it up is because you'll see in the other one, might be a little harder to see. This one's at 0. That's where the middle is. So that's cutting right through the middle of that function. So ours is cutting through at the value of 6. And the amplitude tells you how far to the top and the bottom it goes. So the peak and the trough. So we know we're going to go at least 3 units up. So let's say 3 is every, how did I scale this? 2, 4, 6, 8. Okay, so we got 2, 4, 6, 8, 10, and then 12. Okay, so if we were to go up 3, that means our peak, I'll draw it with another line, we'll say it'll be a red line here. Our peak is at 9, and the reason I know it's at 9 is because the amplitude is 3, so we're going to add 3, okay, to our equation of the axis. And our trough, the lowest point, we'll do that in, I don't know, we'll do it in blue. Okay, we would subtract 3, so it's going to be at a value of 3. And in that case, and I know it's at 3 because I do the same thing, except I subtract by 3 to find out the lowest part of it. Okay, so essentially what we're going to be doing to draw this is we're going to be drawing something that's periodic, could be like this, that has peaks and troughs there. It could even start here and do this. Okay, they haven't really filled up much more information. It could become a box-like. It could be our similar one like this. That looks all very, very messy. But each of them technically represent a periodic function with a peak being at our value of 9, Does it make sense how we found the
Yeah.
highest point? Our value of 9. Our trough, or lowest point, being at a value of 3. And the equation of the axis, I guess we'll put it in green, being the number 6. So anything in there is acceptable. So, I mean, let's make something real funny looking here. I'll kind of do, let's see if I can repeat that. Right? And here's the real key here. The other last thing that we haven't filled out is that the period is 6. Okay? So what it means is at this point, okay, if we're starting at wherever it was at 0, that's where it has to repeat. Okay, so we're going to draw another imaginary line. And now that one I did in there isn't exactly that. I just wanted to show that it was periodic. So we'll use this red line, a vertical one. So it does its repeating pattern within 6 seconds because we decided to be seconds. So all the way up to 12, that means it would repeat the pattern twice. So let's kind of erase what we have here and try to fill something out that'd be a little nicer. Thought I was using the erasing one there. Okay, so again, we can make it really anything we want. If it's going to start in the middle, whatever I do must come back to that middle at that same point. Okay, let's say it was something diff. Maybe it was like a triangle. Okay, whatever it's doing has to come back at that 6. We have to be approaching that same point in the same way. Obviously, I used 2 different ones there. Okay, so really the periodic function could be anything because those are really all the parameters they've given us, just as long as it fulfills what we were looking at. So let's build one else. If it started at the top, like our other one did, okay, it'd have to come back to the top again at that point, come down, come up again. That would technically be periodic. So any of those are acceptable periodic functions that fulfill what we were looking at.